Hello and welcome to 4th grade Unit 1. We're going to be talking about place value to the millions. Please have this note sheet ready along with a notebook. Be prepared to try some practice problems and rewatch any parts of the video that you are having trouble understanding. Good luck. Here we go. The first thing I want to talk about is place value drawings. The place value drawings are a dot for the ones, a stick for the tens, a square for the hundreds, and a rectangle for the thousands. The reason this works is if I stacked 10 dots on top of each other, I would end up with a stick. If I took 10 sticks and I lined them up next to each other, I would end up with a square. And if I took 10 squares and stacked them on top of each other, I would end up with a rectangle. So I can get to each of my values by taking 10 to them, because ones are 10 times smaller than tens. Tens are 10 times smaller than hundreds. So that's where these shapes come from and why they make sense. The next thing we're going to talk about is forms of numbers. We have standard form, expanded form, and word form. Each of these are important forms in order to know how to convert types of numbers. Standard form means just number form. So that's when we're going to see our numbers in numbers. Expanded form means we're going to expand out each place value. So the number 982 has 900, plus it has 80, plus it has 2. And then word form, 982. We must include commas where commas are present, which would be here after the thousands. It would be here after the millions. And we have to have a hyphen, that's that little dash in the air, between the tens and ones digit. We have to have that anytime there's tens to ones digits. So if we look at our place value chart below, we have ones, tens, hundreds, comma. The comma denotes a new place value system. We then have 1,000s, 10,000s, 100,000s. So we're repeating the pattern of ones, tens, hundreds. So if I had a 10,000s number and a 1,000s number, I'm going to have to put a hyphen between them when I write them out in word form. So it doesn't matter if it shows up in the ones and tens, or the ones to 10,000s, or the ones to 10 millions, or the ones to tens billions, and so on and so forth. We also have to, again, remember those commas because those are equally important. Make sure you know this portion of the place value chart going into this unit. If you don't know these by heart, start memorizing, practice, create a song, whatever it might be to help you understand those place value words and positions. All right, the next thing we're going to talk about is input and output tables. This is not on the note sheet, so you're going to want to take some extra care and maybe some extra notes during this section. Input, output, as we've done some different activities, sometimes you see it as like a machine. We are putting a number in, it goes through some type of rule, and it spits out a new number. So in this example over here, if we put in a 4 and we get to 12, what the rule is multiplying by 3. Now, what we know is input-output tables become a big portion of graphing when we start getting into graphing units later in our education system. So the input is always the variable x. Output is always the variable y. So when we create a rule, we should start utilizing those terms. What did happen to the x? It multiplied by 3. So we know that if we put a number first and then a variable, a letter, number next to letter means we're multiplying. So 3x, because we multiplied the x, the input, by 3. And then it's going to equal our output, which represents the variable y. So this would be the correct equation to use. Now, we can take any of these input numbers and put them into the x, and we'll solve for the y, or the output. We could take any of our output numbers and put it in for the y, and we could solve it in inverse operation with division to come up with the x. Let's take a look at our example. The first thing we want to do is try to find our rule or pattern. How did we get from 7 to 42? Hopefully you thought times 6. Now we're going to have to go find another row. 6 times 6, does that get us to 36? Yes, it does. 4 times 6, 24? Yes. So our rule is multiplying by 6. Now, if I wanted to write an equation for this, I would write out 6x equals y. Now I can use this equation to solve for any of our missing. So if I am missing the y, but I know the x is 8, I can put 8 in here for this equation, and it would say 6 times 8. And then I would solve for my y. 6 times 8 is 48. For the next one, I don't know the x, so I could write a new equation saying y divided by 6, which is the inverse operation of what we did to solve the last one, equals my x. So if 54 is my y, 54 divided by 6 equals my x. So my x is going to be 9. If I look down at the bottom, I know my x, so I'm going to go back to the equation of 6x equals y. Oops, equals y. So 5 times 6 gets me my y, which is 30. The next thing we're going to talk about is addition. There are many different methods that we can utilize to get to adding large place values. The new groups above method is one of the most common methods that we use in adding big numbers. Let's practice that method with our example. If I did 8 plus 5, I'm going to get 13. I bring the 3 down. I regroup my tens digit to the next place value. Now, when I make my one above, as you can see in this example, they're teeny tiny. I like to make mine equally as big as my other numbers in that row. The reason I do this is I won't miss that number now. Sometimes when you make it teeny tiny, it gets lost in the numbers. So make it just as big, it'll help you. 1 plus 7 plus 9 is 17. Carry our 1. 1 plus 2 plus 6 is 7. And 6 plus nothing is 6. Now we're going to go put in our place value marker, which is the comma. So our answer is 6,773. Subtracting across where we need to borrow. Usually we're going to use the method of the US method here. Now, when we have a whole bunch of digits that we need to borrow from, we can do a simple trick. But before we do that, let's talk about, we always start on the right side. Can I do 0 minus 6? If I have 0 pencils, can I take away 6? No. So I need to borrow, and when I borrow, I'm going to just borrow from next door. Well, next door is a 0, so I have to go next door. Whoops, that's a 0. So I have to go next door. In this case, I have to go all the way to the thousands digit to borrow one. What I'm borrowing is 10 because each place value is 10 times bigger or smaller than the one next door. So if I borrowed 6, this would become 10. I borrow, so it would become 9. This one would become 10. I borrow, so it's 9. And then the last one becomes 10. A lot of times I see people cross out the last one and they end up making it 9, and then you end up with a wrong answer. If I had 10 plus 9 plus 9 plus the 6, I would end up with my 7,000 there for each of the place values it was, because the 10 would bump up this 9 to 10, which would bump up this 9 to 10, which would bump up this 6 to 7. Now I can do my subtraction. 10 minus 6 is 4. 9 minus 5 is 4. 9 minus 4 is 5. We're going to put my comma in, and 6 minus 3 is 3. So I end up with an answer of 3,544. Now, if subtraction is difficult for you, go back and add your two parts together. This would be a part, and your answer would be a part. And if you add those together, it should equal back to your total. Whoops, not their total. Their total, the 7,000. All right, moving on. Comparing numbers. A lot of times when we compare numbers, you're going to see these boxes more circular shape. When we compare numbers, we're going to be using the symbols of greater than. The first side is bigger or greater than the second side. Less than, the first side is less or smaller than the second side. And then equal to. If you've done a lot of Dreambox, you maybe have had Ellie the alligator munching on her big numbers. Ellie the alligator always loves to eat big scrumptious numbers. Scrumptious. I like to use Pac-Man. And Pac-Man also likes to eat the bigger numbers, since this usually is circular shape. Now, to prove our answers, the first thing we're going to do is count how many digits we have on the left and how many digits we have on the right. We have 4 digits on the right and 4 digits on the left. So the next thing we're going to do is start eliminating place values. In the thousands, and we always start with the biggest, they both say 6. The next place value is the hundreds. It's the next largest place value. And oops, I see 2 different numbers. I'm going to circle them. Which one's bigger, 7 or 3? Hopefully you said 7. So my Pac-Man, and I always draw my little eyeball, my Pac-Man's going to eat the bigger number. So this one's a greater than. In the next one, I have 4 digits, 4 digits. So I'm going to start eliminating. I have a 3 on both sides. Oops, I have a 7 and I have a 2. So again, it was the hundreds place value. And 7 is bigger than 2, or 7 is greater than 2. Another way we can always order numbers, especially if we're ordering them and you have many numbers, you can stack them on top of each other. So I could have put the 3, the 2, the 6, and the 7 and kind of done the same process. The 3's are the same. Oops, right here is where they were different. So that helps if you're going to be organizing more than two numbers together. All right, this is our last concept, rounding numbers. If you were to do a word problem, it's going to use the word about. So if you see the word about, we're going to be using some rounding. Anytime we do any type of estimation, we're going to utilize rounding. Now, if we are doing estimation, we need to round to the highest place value that any of the numbers in the problem share. So if one number has in the thousands and the other number has hundreds, the highest place value they both share is hundreds. So we would round to the hundreds. How we round? We first underline the digit we're rounding to. So in our examples, the underline is already done for us. We're then going to look at the digit behind it. So in this case, the 2. And I'm going to draw an arrow from the 2 to the 5. If I look right here, these are my rounding rules. 0 to 4, we round stay. 5 to 9, we round up. Now, I hear a lot of people always say we round down. Try not to use that term, because when we round down, we think sometimes that we need to make the number smaller. And we aren't going to make the rounding digit any smaller than what it already is. So I like to use the term round stay. So the 2 is telling the 5 to stay. So the 5 is going to stay a 5. Everything in front of it stays. Everything behind it turns to zeros. Let's take a look at the next one. The 1 tells the 3 to stay. Again, it's the number after the underline that's telling it what to do. So the 3 is going to stay a 3. The 1 stays a 1, and everything behind it turns to zeros. I like to write my numbers above because that way I make sure I have the right amount of zeros. Okay, the next one, the 2 tells the other 2 to stay. So that 2 stays a 2. Everything behind the underline turns to zeros. So the term round down came from a problem just like this. This rounding answer is smaller than what we started with. So that's where the term round down comes from. But I don't like that term of round down because when we start getting into decimal rounding, it starts kind of confusing us. So again, try to use that round stay term. So the next one, the 5 tells the 9 to go up. So the 9 becomes a 10. So that's going to be a 0, and I'm going to add one more to this 9. So that's going to become a 10. And the 5 turns to a 0. So in that case, my answer turned to 1,000. Again, if we were doing word problems and it ever said the word about, make sure that you're using these rounding strategies to come up with the correct answer. All right, going back to our practice sheet. Try these problems. Try them on your own. When you think you have all the right answers, resume the video and see if you are correct. Pause the video now. Welcome back. Let's check the answer. Write the number in standard form. 243. So 243 and then 1,000, and I see a comma, so I need a comma. And then it says 12. 12 is the tens and ones digit. So I don't actually have any digits in my hundreds place. So I need a placeholder. So I'm going to place a 0 there. For the next one, I'm going to add. 2 plus 9 is 11. So put one of the ones down, carry the other one up. 1 plus 6 plus 3 is 10. Carry my 1 over. 1 plus 3 plus 8 is 12. Carry my 1 over. 1 plus 8 plus 4 is 13. Carry my 1 over. 1 plus 7 plus 1 is 9. So my answer is 93,201. For the next one of subtracting, I cannot do 0 minus 7, so I needed to borrow. And I had to borrow all the way from the 2. So the 2 becomes a 1. The 0 becomes 10. I borrow, it becomes 9. The next 0 becomes 10. I borrow, it becomes 9. The next 0 becomes 10. I borrow, it becomes 9. And the last 0 becomes 10. 10 minus 7 is 3. 9 minus 5 is 4. 9 minus 3 is 6. 9 minus 4 is 5. And 1 minus nothing is 1. So I get an answer of 15,643. In this next question, I see the word about. How many cans did they collect in all? So I'm going to round my numbers. This one has in the thousands. This number here has hundreds. So the highest place they both share is hundreds. So I'm going to round to the nearest hundred. The 9 tells the 5 to go up. So that's going to be 1,600. And the 8 tells the 7 to go up. So that's 800. Whenever you're doing an about, you should always show what equation you use to come up with your answer, since those are not the actual numbers. So 1,600 plus 800 equals C. And C equals 2,400 cans. The next one, filling in the blanks. If I have 45,000, then I have 450 hundreds. We'll have to fix this sheet. We're going to change the sheet right now to match what it's going to end up looking like on your sheet. So I'm going to change one number here. This number right here is going to be 4,500. That one ended up with one too many zeros. Okay, so how many hundreds are in that? There's 45. Because I know that 45 times 100 is 4,500. So 4,500 equals 4,500 hundreds. The last one, we are rounding to all the different place values that it says. If I'm rounding to the nearest 10, the 2 would tell the 5 to stay, so I get 860,950. If I'm rounding to the 100, the 5 would tell the 9 to go up, so I'm going to get 861,000. In the next one, I'm rounding to the nearest 1,000. The 9 tells the 0 to go up. So I get 861,000. Notice, these two answers are the same. And that can happen when we're rounding to certain place values. The next one says round to the nearest 10,000. The 0 tells the 6 to stay. So you can see here, this answer is actually smaller than these other two answers based on where we were rounding to. And then to the nearest 100,000, the 6 would tell the 8 to go up. Rewatch the video if you need to. Work on any IXLs in Grade 4, Unit 1 Skills Plan. Practice any of the Math Activity Center lesson checks in Think Central. Otherwise, good luck.